We're going to find the greatest common divisor of 144 and 224. Now what I mean by greatest common divisors, I want the largest number that divides evenly into both 144 and 224. Now you remember earlier video, we found a least common multiple by clapping and jumping our way to the answer. We're going to try the same thing here. We're going to clap on every divisor of 144. We're going to jump on every divisor of 224. All right, now, notice we're not looking for the least common divisor. Least common divisor, that would mean we'd stop when we get to the first one. We'd be like, 1, and we'd be done, and that's just ridiculous. We're going for the greatest common divisor. And that means we just keep going. Keep going until we get to the last one. Here we go. Ready? And start. Both, clap, both, rest, clap. Jump, both, clap. That's too tiring. I can't do this. I am too old for this. We need a different way to do this. I mean, besides, we just keep clapping and jumping until we get to the last one. How do we know when we've gotten to the last one? We need a better way to do this. All right. Well, one thing I like to do on some problems is I try to do similar problems. Look at similar problems that I know how to do. And similar problem, well, we did least common multiple, and we did that with prime factorization. So let's take a look at how we did the least common multiple problem, and maybe that'll help us think about how we can do the greatest common divisor problem. So we'll look back at that, and I think the numbers we started with there were 24 and 45. And what we did there is we started with the prime factorizations of 24 and 45. 24, that's 8 times 3, that's 2 cubed times 3 to the first. And 45, well, that's 9 times 5, that's 3 squared times 5 to the first. And we realized that any multiple of 24 has to have at least 3 2's and at least 1 3 in its prime factorization. And any multiple of 45 has to have at least 3 2's and at least 1 5 in its prime factorization. And we use these ideas to build the least common multiple of 24 and 45. In order to be a multiple of 24, we need at least 3 2's. So we stick in 2 to the third. In order to be a multiple of 45 and 24, well, for the 3's, all I need are 2 3's, because I need at least 2 3's for 45. And once I've got 2 3's, I've got 24 taken care of, because I have more than 1 3. And I'm going to need the 1 5 over here for 45. Now, another way I could have looked at this is if I stick in the kind of the missing primes up here, and I put in the 0 power, because anything to the 0 power is 1. Well, one way I can think about this after I put in these 0th powers is I'm just taking the largest power of each prime that appears in the prime factorizations. The 2 cubed, the 3 squared, and the 5 to the first, and I build my least common multiple that way. Well, I mean, that works really nicely for least common multiple. Maybe prime factorizations will help us with divisors. So let's first, before we go on to the greatest common divisor, let's just look at how prime factorizations help us with divisors in general. We'll start with 24 again. That's 2 cubed times 3 to the first. And we'll think about divisors of 24. For example, we know 12 is a divisor of 24, and its prime factorization is 2 squared times 3 to the first. And from the prime factorizations, we can see that 24 is a multiple of 12 because it has at least 2 2's and at least 1 3. And there are no other primes out here for in the prime factorization of 12 that we have to worry about. So because 24 has at least 2 2's and at least 1 3, we know that 24 is a multiple of 12. So 12 is the divisor of 24. Now, let's take a look at 15. 15 is 3 to the first times 5 to the first. Now, 24 has enough 3's to be a multiple of 15, but 24 doesn't have any 5's at all. So 24 is not a multiple of 15. That means 15 is not a divisor of 24. How about 16? 16 is just 2 to the fourth. 2 to the fourth, that's 4 2's. Any multiple of 16 is going to have at least 4 2's. So 24 can't possibly be a multiple of 16. That means 16 can't be a divisor of 24 because 16 has too many 2's in its prime factorization. Any divisor of 24 can't have more than 3 2's in its prime factorization. And also it can't have any more than 1 3 in its prime factorization. And now we know how to find the divisors of 24 from a prime factorization. Any divisor of 24 can have at most 3 2s and at most 1 3. It can't have extra primes. It can't have too many 2s. It can't have too many 3s. But any number that has at most 3 2s and at most 1 3 in its prime factorization and no other primes, that's a divisor of 24. For example, if I take 8, 8 is just 2 cubed, doesn't have more than 3 2s, doesn't have any other primes other than 2 and 3. That's a divisor of 24. If I did 6, that's 2 to the first times 3 to the first, doesn't have more than 3 2s, doesn't have more than 1 3. This is a divisor of 24. It doesn't have any other primes either. So now we know how to use prime factorization to find divisors. So let's go back to the greatest common divisor of 144 and 224. And we'll have to start by finding some prime factorizations. Well, 144, that's 12 squared. And 12 is 4 times 3. That's 2 squared times 3. And we're going to square that. So 2 squared squared, that gives us 4 2s. And we're going to square that 3. We have 3 squared. All right, so we got the prime factorization of 144. Let's move on to 224. Well, we know that's divisible by 4 because 24, the last 2 digits, that's divisible by 4. 200 divided by 4 is 50. 24 divided by 4 is 6. So 224 is 4 times 56. 56, of course, that's just 7 times 8. So this is 2 squared times 7 times 2 cubed. And the 2 squared and the 2 cubed go together. They give us 2 to the 5th. We don't have any 3s. I'm going to put the 7 over here. Times 7 to the 1st. And we have our prime factorization of 224. It's 2 to the 5th times 7 to the 1st. And now we're ready to build our greatest common divisor. And once again, we're going to look at it prime by prime. We'll look at the 2s. A divisor of 144 can have no more than 4 2s. A divisor of 224 can have no more than 5 2s. Now we want to take as many 2s as we possibly can because we want the G, the greatest common divisor. So we'll go ahead and we'll take 4 of those 2s. We have 4 2s. We can't take more than 4 2s or it won't possibly be a divisor of 144. So we have to stop at 4 2s. But we can take 4. Now we'll move on to the 3s. We can't take any 3s or the number won't be a divisor of 224. We can't take any 7s, or the number won't be a divisor of 144. So we can't take anything else. Can't take any more primes either. Now another way we could have looked at this, we could again have stuck in the missing primes. And we see that in building our GCD, well, if we look back at the LCM, we took the highest power of each prime after we put these zeros in. In building the GCD, we're going to take the lowest power of each prime. Again, we have to remember to put in our 0th powers, but once we put these in, we're taking the lowest power of each one. And all we're left with here is 2 to the 4th. And that's our GCD. And 2 to the 4th, hey, that's 16. And we're done.